Hello everyone, we are going to talk about event graphing today. We're going to describe the relationship between two quantities using data from events on a coordinate grid in a table of values. The entrance slip, talking about the last lesson. We're talking about linear functions. The linear functions listed below, are they direct variations? Yes or no? So just remember, direct variation must have a y-intercept of 0. And if I could get that to work, yes. So direct variations are straight linear functions that go through the origin with a y-intercept of 0. This does have a y-intercept of 0, so that means we are going to say that this is a direct variation. We are going to say right now 10x plus 20 equals 5y is not a direct variation. If you went to go and solve it, which you don't have to do, you would just go to divide by 5 on both sides. This cancels y equals, and then 2x, because 10 divided by 5 is 2x, 10x divided by 5 is 2x, and then 20 divided by 5 is 4. See how that is not a direct variation. The b is 4, so that means it's not a direct variation. Doesn't go through the origin. Right now, just looking at 9x equals 4y, you know that this is a direct variation. So we see that right now we're probably not going to have a b of like 2 or 3 or 4. The b is going to be 0. So we're going to divide by 4 just to make sense of it. And this is 9 over 4x. The slope is 9 over 4, but the b is 0. And that's what you need to have a direct variation. This page right here, the graph of the linear function, y equals mx plus 1 passes through the point 3, 7. So let's look at the information that is given here. And first off, which statement about the linear function is true? So they give you this function here, and then they give you a point here. So just remember, the b that they're giving you, here's the b, is 0. Sorry, it's not 0. It's 1. Something about this. The y-intercept is 0? No, it is not. The y-intercept is 7? No, it's not. It's 1. The slope is positive. The slope is negative. There are a couple of ways that you could do this, but I like sketching. So if I sketch on my grid, I'm going to go and just go like that. That's all you have to do. So we're going to have a y here, and we're going to have our x here. So this y-intercept, just remember the b equals 1 and the y-intercept is 0, 1. So if the b equals 1, it's right there. The other point that they give us is 3, 7, which is right here. So if you're looking at this right now, and there's the point, there's the line that the two points create if you connect them, and I'm going to move that down, and then I'm going to put arrows on the ends even though it's my sketch. What is that slope, positive or negative? It is positive. That's it. Simple. Just remember the y-intercept is given, a point is given, you could sketch it, and this one is history. All right, in this lesson, we're going to talk about event graphing. And basically, all it is, events on graphs. What I do want to say about this event graphing is that you are not going up a hill at all. It looks like you're climbing up a hill. You're not. Just reminder, know what's on the y-axis, know what's on the x-axis, and then you will be good to go. So Joe is going to Vinny's house on foot. On the way, he meets Tara and talks. He arrives and gets a ride home. So I'm just going to sketch something. I'm just going to highlight the information here. So Joe is going to Vinny's house on foot. So right here is Joe's house, and Vinny's house on foot right here. He's starting to walk to Vinny's house on foot. On the way, he meets Tara and talks. So right here is where he's meeting Tara and talks. So he starts walking. Then he meets Tara. And then I'm going to go back to the highlighter. He arrives and then gets a ride home. So now after he finishes talking to Tara, he continues walking again. So you can see this, that he's walking again. So I'm going to put walking after he finishes talking to Tara. He arrives at Vin's house. Obviously right here is where he's staying at Vin's house. And then he gets a ride home. Let me just go and see if I could change that to blue. That would be nice. Yep, he gets a ride home right there. So let me just go, and this is Vin's house. And this is the drive home. I'm trying to write sideways, and sometimes that doesn't work. Okay, so when does he meet Tara? All right, when does he meet Tara? Right here at 2 p.m. He meets Tara. At 2 p.m. How long do they talk? Well, let's see, right here to here. So it's 2 to 2:30, so that's 30 minutes. Is Joe walking faster from 1 to 2, or from 2:30 to 3? Joe is walking faster from 2:30 to 3. It's a steeper line, so his rate has increased. And so I put Joe is walking faster from 2:30 to 3. The line is steeper, which indicates his rate is faster. There's no need for you to actually break it down into the actual numbers unless they ask for them. So you're just looking at the lines. The steeper line has the faster rate. When does he get to Vinny's? Well, let me draw a dotted line down. And this is Vin's house. So he gets to Vinny's at 3 p.m. When does he leave? Let me draw a dotted line down. He leaves at 6 p.m. When does he get home? This is when he gets home. So it's between 6 and 6:30, which is 6:15. How can we tell the ride home was faster than the rate he was walking? Well, it's the same thing. It's a steeper line, so that indicates a faster rate. And that is the answer. It's a steeper line, and you could see that they cover 6 miles in 15 minutes. Definitely, that's a steeper rate, and it's a faster rate, and it's a steeper line. So either way, you really don't have to break down the numbers. You just have to answer that question looking at the line. All right, this is a bicycle club ride. Did the bicycle club ride at a constant rate the entire time? Justify your answer. Looking at the graph, the only time that you have a constant rate of riding is if you had a straight line from beginning to end. If it was a straight line from beginning to end, this would be a constant rate. It is not a straight line, so that means they have different rates varied along their path. And there it is. They did not ride at a constant rate because the line shown is not straight. The rate is not constant. If it were, then the line would be straight. The rise over run would be the same. The rate would be the same, and the line would be linear. All right, describe what happened at 3 hours. To describe what happened at 3 hours, I'm going to go and take my pencil and draw a dotted line down at 3 hours. And this is the part that they're talking about right here. What happened at 3 hours right there? All right, so this point right here, they have stopped. The distance is the same for about an hour. Like, so in an hour's time, they covered no distance. So what happened? They took a break. All right, they stopped riding. And remember, they stopped riding, and you could tell just by saying, okay, in that hour, no distance was covered. Distance remained the same. So that's why you know that they stopped riding, and maybe they took a break for an hour. They had lunch. And you can see the answer that I typed right there. At what hour did they ride the fastest? All right, so let's talk about the fastest hour. So to do this, we're just going to go and break everything up into the hours. So that is 1 hour right there. And we're talking about another hour right there. A 3 and a 4 and a 5. The 5, this hour right here. Good. And then we're going to talk about the last final hour. All right, a little bit difficult here, but we're going to talk about 10 miles per hour. Right here, you could see that the 1 hour represents 10 miles right there. Right, so in the second hour, we're going to have the we start from 10 and we're going up to around 18, so we're going to say 8 around here. All right, so it gets about 8, and then from 18 to about 32. So from 18 to 32, that's 14 hours, 14 miles. And then 0 miles right here. And then we have from like maybe 32 or 30, whatever I said that was, this was 32, and to about 38. That's 6. And it's approximately, so it's not really, a perfect situation here. But this right here, maybe it'd be 38, and then it would go up to 50, so this would be 12. So the fastest, you could see that they rode the fastest between the second and third hour, just before they took a break, and then right after the break, they rode the slowest. And you could see that they rode the fastest in this 2 to 3 hour, covering approximately 14 miles, and the slowest in the 4 to 5 hour. It's right after the break, and that's just 6 miles. This is what I put for the possible explanations and difference of speeds. They rode the fastest because they were looking forward to the break. You know, when you're looking forward to a break, you know it's coming, and they just wanted to get to a certain location. about 32 miles away from when they started. That's a lot. So they're really looking forward to it. So they were riding fast. After the break, they took an hour break and they were kind of like slow to get back onto the bikes. And maybe they finished eating or something and they just wanted to, they just got on the bikes and they just had trouble getting up to the pace again of what they were riding at first. All right, and that's about it. Those are possible explanations. Not every explanation is like that. Maybe they were going up or down a hill. For going down a hill would be going at a faster, make you go at a faster pace, riding a bike. Going uphill would make you go a little bit slower. So terrain might have had something to do with it, but this is just one possible explanation. So Kyle got into his car and steadily accelerated to the speed limit. After driving at a constant rate of speed for a while, he slowed to a stop and parked in a store parking lot. Kyle spent a few minutes shopping, and then he re-entered his car to drive home. He accelerated to the speed limit, continued at that speed for a while, and then slowed to a stop, parked in his driveway. Which graph represents all of that info above? Really, the only way to do this is to go graph by graph and situation by situation as you read. So that's what we're going to do, and we're going to use a highlighter to do it. Kyle got into his car and steadily accelerated to the speed limit. So we're going to take the highlighter and steadily accelerate to the speed limit. After driving at a constant rate of speed for a while, that's what he did, constant rate of speed. He slowed to a stop. He goes slow to a stop, then parked in a store parking lot. So that could be the answer, but let's see if we go. Kyle spent a few minutes shopping, then re-entered his car to drive home. He accelerated to the speed limit. This does not have any of that second part of the information down, so I'm going to cancel this out right away. So let's go back and see if we can do this with C. So Kyle got into his car, steadily accelerated to the speed limit. He drove at a constant rate for a while. That's good. He slowed to a stop. Here we go. We're slowing to a stop. There's the stop, the speed. You see the speed right here? The speed is big because this is 0. Right? 0 speed. So he slowed to a stop right there, and this is his stop. He slowed to a stop and parked in a store parking lot. This is him parking. Kyle spent a few minutes shopping, then re-entered the car to drive home. He accelerated to the speed limit again. Same speed limit as this right here. So far it looks good. They continued at the continued speed for a while, and then slowed to a stop and parked in his driveway. C looks like you are having that answer there, and C looks like it's good enough. By the way, this is slowing to a stop and parking. So this B doesn't even slow to a stop and park. He continues on forever. This is not a stop. See, a lot of people think that's a stop, but if this is 5-10 miles an hour, just realize that's a constant rate. So is this, like 15, 20. If you have to put numbers in, then put the numbers in to understand it. But C is your answer. That's where he parks. He slows to a stop. He parks his car in a store parking lot. Then he spends a few minutes parking and shopping, and then he goes and re-enters the car to drive home. He continues. He re-enters his car and accelerates to the speed limit, continuing for a while. That's this right here, and then he slows to a stop and then parks at home. All right, in his driveway. And that is it. So we're talking about an investigation here, and we're going to just zoom this in to the full page. The graph to the right represents a cup of coffee, which is over a period of time in X hours. So the temperature is Y and the hours, those are X. So in which intervals does the temperature remain the same? So I'm going to go draw the dotted line. You see the temperature remaining the same right there. So B and D, B and D. What is the temperature of coffee during interval D? So I'm just going to draw a dotted line right all the way to the center of there. So I'm going to put some numbers in. This is 20, this is 40, this is 60, that's 80, this is 100, this is 120, that is 140. Right? And you could put 180. Okay, so this is 20, this is 40, in between there is 30 degrees, so that's what I'm going to put, 30 degrees Fahrenheit. Describe what is happening in interval B. Well, the temperature is remaining the same. The temperature remains 60 degrees. And the temperature remains 60 degrees. Maybe it hit room temperature, or like it was left outside and it was 60 degrees outside, and it just hit whatever the temperature was in the atmosphere at that time. Maybe it hit that temperature, and that's it. All right. So the coffee obviously started at it was very hot, just under 200 degrees Fahrenheit. So, and then it went down within 1 hour to 60 degrees and remained there for a half hour. And then it went down further. All right. So just remember what's happening in B. The temperature of the coffee remains 60 degrees. We're going to skip that fast finisher, and we're just going to go to this investigation, because this is something that they do ask, and they will ask either on an 8th grade exam or on a Regents. You just have to understand the intervals that the function is increasing or decreasing, or whatever they're asking. So just remember, whenever they're asking about an increase, they're talking about a line that goes up from left to right. Whenever they're talking about a decrease, they're talking about a line that is going down from left to right. So this one, they want to know is which intervals is the function increasing. So we're going to go and just put, okay, we're going to highlight the increasing intervals right here and here. There is nowhere else on this graph that is increasing, that's going up from left to right. So from the start of this point, we're going to say that's -4. It stops increasing at -2. -4, -2, -4, -2. These are out. All right. This one says x is greater than -4 and x is less than -2. That's what that says. X is greater than -4 and x is less than -2. Greater than -4 and less than -2. So we have those two numbers. We're good to go. It starts increasing again at 0, and it stops increasing at 2. So 0, 2, B is your answer. This is -1 and 1. That is not the case. B is your answer. And that's how you do that one. If they were asking for decrease, then this would be, these would be the highlighted portions. All right, going down from left to right. All right, so think on your first, then discuss. The graph below shows one trip from home to school and back. The trip combines walking and get a ride for a neighbor. Tell which part of the graph, tell what the graph shows by labeling each part. I already labeled the parts for you, so we're going to just go ahead and put these in, and we're going to just make sense of every single part. So this is the entire thing. A, you could see Jerry leaves home and starts walking to a neighbor's house. B, Jerry waits for the neighbor to come out of her house. Jerry gets a ride. Then C, Jerry gets a ride from the neighbor to school. That is a steeper line, so it's a drive. It's a ride from the neighbor in a car. And then she stays at school for the entire day. That's D. At the end of the day, Jerry meets the neighbor, gets a ride back to the neighbor's house. That's E. It's a steep line. And then F, Jerry talks to the neighbor for a short time. This is a short time. And then Jerry walks home and arrives at her house, which is right here. And that's really just from A to G, breaking down each section of the graph and then just telling what the graph shows, labeling each part. And that's basically it. In this page, same thing. We're going to go ahead and look at the graphs. I'll explain it when I come back. And just take a look. Speed. You're speeding up in A to the speed limit maybe. And B, you're maintaining your speed. C, you're decreasing speed down to 0. Maybe that you're home. Okay, there you go. The car is increasing speed. Look at A. Going up to A right here is increasing speed to the speed limit. The speed limit might be here. The car drives at a constant speed right here. That's the constant speed, B. C, the car gradually slows down and stops and then it stops right here. And the car has arrived at the grocery store at D. And now we're going to take a look at the second graph. The graph represents the balance of a savings account over time. So here it is. The savings account begins with an initial value. The initial value is right here. And you can see it right there with A. That's the initial value. B, it increases over time. All right, gradually. Then it's basically at C right there. And you could see it remains the same in that time. D, it increases at a higher rate. And then all of a sudden, something happens where there's withdrawals, and the balance decreases to 0, which is right here over like some time, right? So it wasn't completely closed all at once, because if it was closed all at once, then the line would go straight down vertically, and it's not doing that. So this had to be a number of like withdrawals over time and no deposits. So number 3, the last graph, that represents the height of the baseball after it is hit. We'll come back with A, B, C, and D already on there. Okay, the baseball's hit from an initial height, and you can see the initial height right here. There's your initial height. The baseball, after the baseball's hit, the height increases gradually, and that's where you see A right here. And after the baseball's hit, like I said, the B, it increases gradually A from the initial height, and then this one right here is initially it's going up, and then C, baseball's decreasing in height a little bit, and then it just hits 0, which is right there. Okay, and that is about it for that page. Okay. Okay, so here's another investigation. We're going to show in this graph the time shown on the x-axis is speed. I'm sorry. The time shown is on the x-axis, and the speed is shown on the y-axis. And they're going to ask you questions based on this graph, so that's why it's called graph interpretation. All right? So here we go with this one. What part of the graph is the speed remaining the same? So I'm going to grab my highlighter, and I'm going to go that the speed right here, and that's not a highlighter, but the speed is remaining the same right there. The speed is not remaining the same here or here. It's decreasing here or here or here. So the speed remains the same, and we're going to put this from A to B. Describe what is happening from C to D. So I'm going to put draw my little dotted lines down. C to D, the speed is decreasing. What part of the graph is the speed increasing at a constant rate? So this is not a constant rate. You see how this right here from B to C is a curve? That is not a constant rate. This is not increasing at a constant rate. This is not from D to E is not increasing at a constant rate. And I'm going to say right here, this is increasing at a constant rate from E to F. Increasing at a constant from F to G. So constant, straight line, constant to G. So it's constant and constant. So E to F and F to G. Okay, so which interval has the greater rate? So E to F or F to G. So F to G definitely has the greater rate. We're going to put that down immediately. And the reason why, how can you tell? It has a steeper line. Line is steeper. And when the line is steeper, it indicates a greater rate, a greater speed. And that is it. All right, so the exit slip, we're up to this right now. The last question on this entire lesson. Sarita walked from her home to a park. The graph below represents the relationship between time that passes and Sarita's distance from her home. What event could the segment between x equals 7 and x equals 9 represent? So I'm just going to number 6, 7, 8, 10. And then 7 and 9 is right here. They always ask about that flat surface right there. And just remember what I said to begin this whole thing, this whole lesson. We are talking about distance from home. All right. It is not speed now. Sometimes it's speed, but now it is distance from home. So if this is distance from home right here to here, she is not covering any distance in those 2 minutes. All right. So she went back home. No, she did not go back home. She did not cover any distance, but she did not turn back home. She stopped to talk to a friend. That is possible, so we're going to put a check mark. She walked to the store before going to the park. That's not it. So I don't think that's it. I mean, it's a possibility, but she walked to the store. Okay. In 2 minutes, that's what, like, the store trip is? No, it's not. She probably met a friend. She stopped to talk to a friend. She's not walking at a constant speed. Again, just remember, a constant speed is a straight line. So she's not walking at a constant speed throughout. She actually started home. She was at home. She was walking to the park, then forgot something at home, probably. And then started walking to the park again, met a friend right here from 7 to 9 minutes, and then continued on. She at the park right there. And so B is your answer. She stopped to talk to a friend. How many minutes did Sarita return home to forget something minutes. So we're going to talk about this right here. At how many minutes did she return home? But she did return home right here. So we're going to say 4 minutes. She turned around at that time. It's a weird question, but at 4 minutes, she actually returned home. Interval did Sarita walk at the slowest rate? And I'm going to say from 9. She was pretty quick here. We're just still going about the lines. This is not a steep line, so she's walking at a very slow rate. So I'm just going to put the numbers together. This is from 9 to 13. How far is the park from Sarita's home in feet? And then I'm just going to go and make a dotted line all the way there. And I'm going to put some numbers in. If this is 250, this line here is 125. If this is 500 and it's going by 125, this is 375. 100 and then by 125 is 625. So it's 625 feet. Okay, so that is the exit slip. That was the exit slip, and that is it for the lesson. Pretty easy lesson going here. Just remember, look at what the y-axis and the x-axis represents before answering these questions. Make sure you use a highlighter. Make sure you use your dotted lines down to the x, down to the y, or up, over to the y. Just like I did in this video. And as always, thank you for watching, and we hope that helped. See you next time.